Well, we've got a really interesting topic today. We're going to talk about something that's critical for, this is something that's really critical for chemistry. This is one of those things that I remember, this is one of the things that I remember when I took chemistry, that I really, I remember having a tough time with this, thinking, now what in the world are they doing? So I'm going to try to really take our time here and try to walk you through it. What we're going to do is something called oxidation numbers. So the first thing I'm looking at here is oxidation used to be, okay, the old definition for oxidation used to be a substance that had reacted with oxygen, okay. So, so a typical example there, okay, so a typical example would be this chemical formula here where Fe is iron, okay. So iron plus water yields iron oxide plus H2, which is a hydrogen gas. So this is the old, I'll ask you on your test, what's the old definition for oxidation? A substance that had reacted with oxygen. And here's a chemical formula to show the old oxidation number, and this is rust, okay, the formula for rust. Now, we've changed that a lot through the years, and now oxidation number is actually the apparent charge, okay, it's right here, the apparent charge of an atom or a molecule, okay? So somehow things have become a charge. Now why is this such a big thing when we talk about oxidation numbers? Because the minute that something is exposed to the air, okay, it's exposed to oxygen and it combines in a way that we have oxygen combining with something right away. Well, what else is in the air? Hydrogen. Hydrogen's big in the air, different things. So what we have is we're going to calculate oxidation numbers. So the first thing I'm going to do, and this is kind of where I want to break this down a little bit. I want to come back and I want to talk to you about through the years I've kind of developed 4 rules, okay? And this is if you'll memorize these 4 rules, you'll be pretty foolproof on this, okay? So here we go. Let's look at this. So rules for determining oxidation numbers. Okay. So now, oxidation of an atom in the uncombined state is 0. Okay. So for example, if I say what's the oxidation number of, let's just say sodium. Okay. Well, that's not combined with anything. That's just by itself. So what's the charge of that? The charge of that, the oxidation number equals 0. Or we can do any other element on the periodic table. We could do oxygen, we could do carbon, any other element on the periodic table, when it's uncombined, in its uncombined state, it's 0. Now that's the first rule, and that seems really simple. You're like, oh, that doesn't take a rocket science to figure that out, but that's the one you'll forget, and you'll see what I mean here in a little while. Okay, so now rule number 2 deals with hydrogen, okay? The oxidation number for hydrogen is +1 unless it's combined with groups 1 or 2, then hydrogen is -1, okay? So let's take hydrochloric acid, for example, HCl, okay? So we say, okay, so right away we say, oh, well, that chlorine is combined with a hydrogen. Well, hydrogen is in group 1, but chlorine is not, okay? And chlorine is not in group 2. As a matter of fact, chlorine is over here in group 17, okay? So it's not combined, so hydrogen is not combined with groups 1 or 2. So what does that mean? So that means hydrogen is +1. Oh, well, the charge of all of the elements and all the compounds is going to be 0. They're going to come out to be stable, okay? So if I know the charge of hydrogen is +1, then what's the charge of chlorine? It's going to be -1. Oh, so there are the oxidation numbers for the hydrogen and the chlorine in hydrochloric acid, okay? Well, let's do another one. Let's say we have let's do hydrogen and magnesium. Okay. Now in this case, magnesium is in group 2. Okay. So this rule says, all right, that hydrogen is +1 unless combined with groups 1 or 2. Then hydrogen is -1. Well, since magnesium is in group 2, our rule says that hydrogen then is -1, and it's pretty simple from then on out, because now we have to make this a stable element, or stable molecule, okay, stable compound. So if hydrogen's -1, then magnesium would be +1. Oh, and we'll do lots of examples later. So if it has hydrogen, it's +1 when combined with group 1 or 2, and if it's unless it's combined with groups 1 or 2, and then it's -1. So now we have oxygen, okay? Now we have oxygen. Rule number 3 is oxygen. Oxygen is -2 except in peroxides. Now, let's talk about what a peroxide is here, okay? So this is a peroxide, hydrogen peroxide, H2O2. But I'm going to take this hydrogen off because a peroxide is anything to O2, okay? Anything to O2. And the name of that peroxide, Peroxide, okay, we're used to hydrogen peroxide. Hydrogen peroxide we used to put on cuts and everything to kill all the bacteria, and that's still good. That definitely kills the bacteria. But what happens when we put hydrogen peroxide on our skin or whatever? It bubbles up, and all of that oxygen is bubbling up, and that's good. But now what we're finding is we're not so quick to put hydrogen peroxide on our cuts because they usually form a scar. Oh. So, you know, I mean, growing up, I know my parents put hydrogen peroxide on all these cuts. Well, I got lots of little scars, so thank you, okay? But then they say, well, you didn't die of, you know, bacterial poisoning. So they say, you're welcome. Okay, so now you have to decide if you want to take hydrogen peroxide and put it on. If you have hydrogen peroxide and you're putting it on a cut on your face or something, remember, you're probably going to get a small scar. Now, chemically, why are we getting a small scar? The reason we're getting that is because that's pulling the oxygen out of the cells, and it's causing these cells then, okay, it's causing the cells to die and form the scar. Scar tissue is not living tissue, okay? Scar tissue is fill-in tissue, okay? So there we go. So we got hydrogen peroxide. Now, if I put Na, which is sodium, in here, then this would be sodium peroxide, all right? So let's look at this, and let's do hydrogen peroxide, H2O2, okay? So if this was the rule, okay, if this was a rule, oxygen is -2, except in peroxides where it's +2. So I would put a +2 here. Why? Because it's a peroxide, okay? So now this is O2, and this is an H2, so this would be a -2. Why? Because it would be a 0 charge. So here we have a -4, then we have a +4, which makes a 0 charge. Now, let's put something together. Let's put another oxygen together, okay? Let's put another oxygen together. And let's say that we've got, well, let's do iron oxide, FeO, okay? So in this case, we look at oxygen, we say oxygen is -2, all right, except in peroxide. So FeO, that's not a peroxide. So that oxygen then is a -2, all right? So then we can figure out iron because the stable charge is going to be 0, so this will be a +2, okay? So once again, we're in the process of trying to make things stable. You remember we talked about chemistry at the very beginning, it's about making things stable. Well, when we have oxygen combining with stuff and we have oxidation numbers, then things begin to change, so then they come back to try to make a 0 charge. So once again, the rule number 3, oxygen is -2 except peroxides, okay, where it's a +2. Okay, now, that being said, we're going to cover the third rule, okay? Now, if there's not one of the three, okay, if it's not one of the three, in other words, it's not by itself, okay, or it's not a hydrogen, or it's not an oxygen, then it's the most electronegative. It's the most electronegative number, okay? So if it's not in the top 3, okay, if it's not in the top 3, then we go to the most electronegative number, and the most electronegative number is -1, okay? Now, I'm going to come back on that rule here in a little bit. We're going to give you several examples, but I want you to memorize those 4 rules, and if you know those 4 rules, you're going to be in pretty good shape. Now, this next test is not a test that you have a ton of memorization work, okay? Because you've got, you're going to have the old oxidation formula and the new one, but then you're going to be giving a whole lot of compounds, and I'm going to ask you for all the oxidation numbers. Now, when we did the naming, we did the nomenclature, people were like, oh, well, what does this mean? What does that mean? Now we can look at the charges and say, oh, this one's going to form this charge usually because this is the oxidation number that usually accompanies hydrochloric acid. So hydrochloric acid, HCl, okay, what happens? We have a +1 with hydrogen and a -1 with chlorine, and we end up with an ionic bond because the two come together, 2 ions, okay, we have hydrogen ions and chlorine ions, okay, they make a bond because we have an ionic bond. Now, how did I know that? Because hydrogen is, you see hydrogen? Hydrogen is +1 unless combined in groups 1 or 2. Chlorine is not in groups 1 or 2, so it's a +1. And then what do I do with the other half? I just do enough to make it 0. So hydrogen was +1, chlorine was -1. I'm going to give you a lot of examples. As a matter of fact, the next video we do, we're going to do a ton of examples, okay? So you need to know all of those rules, okay? You need to know all of those rules. Now, am I going to ask you on the test? I'm going to say, what's rule number 1? Nope. I'm just going to say, what's the oxidation number for this? What's the oxidation number for that? Okay, now, we got to separate ourselves out now. Now, then we got a big thing right here. Oxidation number of ions, okay? So now, if I ask you, now, once again, remember, an ion, okay? An ion is a different number of what? Different number of electrons, okay? So now, I want to know the oxidation number of ions. So in order to do that, you skip right over to the periodic table. And I'm going to show you how this works, okay? All right, got some really good students in the room right now that I'm teaching to. It's kind of fun. They're very attentive. All right, now, okay, so when I talk about oxidation numbers of ions, okay, here we go. Let me show you how this works. And this is where when I remember when I was sitting in your in your chair and I was learning this first chemistry information, second semester freshman college chemistry. I didn't understand what they were talking about. So once again, these rules here, I wasn't given those. I was just told memorize oxidation numbers, and I was really confused. Well, this one is really simple, okay? So when I say oxidation number of ions, you go straight to the periodic table. Now, let's look at the periodic table. Okay, now let's look at what does this mean? What does this mean, okay? What does this mean in group 1? Everything in group 1 is 1s1. All right? Everything is 1s1. So what happens is